Yeah, I shared the link to where I'm preparing all the documentation. So what I'm trying to do is whatever I try to explain, I just put it as a document. Of course, explanation is maybe more than the documentation, but I would like to put the things in a document, GitHub, so that later on we can refer or we can share to others as well. uh, Ultimately that is a better way. I really like that way because we can use our own notes. Basically these are all notes what I am making myself, so that they will be used for you as well. Right, just open the link here. This is the essentials for container orchestration. These are the essentials, and this is how we already yesterday I explained how we are going to learn. It's not merely Kubernetes, but the underlying technology uh, of containerization and then Kubernetes orchestration. So this knowledge can be utilized everywhere. Ultimately, this should be utilized everywhere. That's what my intention is. So when you this is for networking things. There is a directory called networking, and then this is how I just put networking 1, 2, 3, and all. The names may differ, but I try to give the numbers. This is what I'm already work in progress. Okay, and FAQ section is something like I just would like to put in the FAQs different things in the networks, whatever the issues we face or whatever from our understanding, whatever we see from the important thing from Stack Overflows or internet or forums. Just we write some FAQs so that we will have some knowledge. uh, and work in progress is I am working myself how to work on the things. This is yet to be formed for you to understand, but this is you don't need to worry. But just the first one, which is called uh, networking OSI model. We have discussed about OSI model, and then we discussed about layer 1 to layer 7 networking stuff in the previous lecture. So uh, yeah, so this is not, I'm not going to do this. Go with that. The second concept, which is called networking devices, which is called network devices. This is the concept. Just would like to explain it a little bit, and then we will go to the third concept, which is of networking basics. Uh, as far as I started working on, I'll explain it, and then we will continue that in the next lecture. So network devices, as we discussed in our previous OSI model. So network is formed uh, with various networking devices. The olden days LANs, you remember the LANs, local area network, that it might be there in your company or in your institute where you learned computers. It's all completely wired. Wires are there, that a wire should come from the your main network to it. Is there are different network topologies those days. It's all completely wired, ethernet based networking. There are cables come, and then inside your LAN all the devices, all your machines are connected through wires. Days are gone now. Now it's all about, if you look at the enterprise grade networking. In an enterprise, generally uh, there are networks inside networks. I'm talking about pretty big companies, but medium organizations where they have employees in hundreds, or they have devices in hundred. They may connect even with they may be connected internally with only one network. Again, that's a topic actually we will discuss about it. So to To really explain about the whole network topologies and then the network architectures, I'm not expert in networking area, but I try my best to learn things so that that would be really helpful for me as a software engineer later on to understand software defined networking. So software defined networking means virtualizing the networks. Okay, instead of this switch, your software work like a switch. Instead of a router, your software work like a router. That we will discuss in the later chapters. So what are switches? These are called switches. The diagram we are seeing here, these are called switches. There are different number of pins are there for the switches. So actually to create a network, switch is very very important. You know, because it is from the switch where you connect, your network is distributed actually. And switch is, always remember that switch is layer 2 networking, but gradually switches comes with very switches. Usually earlier switches were only, they came with firmwares, but nowadays switches are like Cisco or Aruba network or any other switches. These switches are coming with heavily equipped softwares. That means the switch can perform more than what a switch was performing many years ago. Okay, there were hubs as well. Hubs and switches are uh, repeaters. These are all very famous, but hubs, however, nobody is using. Even you don't, very rarely you get. If you want to buy, also it's very difficult to buy because it's a completely gone technology. Switches so replaced hubs, and now switches also came with layer 2, layer 3, layer 4, even layer 4 switches. That means they became very powerful, and then software came into switches. It's okay. So yeah, here if you want to form a network, so in an organization, if you want to form it's a small organization, let us say it's only, it's a startup, only 5-10 people are working on, then you don't need switch. You get your internet connection directly to your router. Okay, the wireless router in your like in your home, and then from there all the devices inside your startup organization, 3, 4, or 5 or 10, they can be connected to, they'll be connected to the wireless routers. But switches form actual networking. The actual networking stuff relies in switches. So switches are important to form network. Most of the network topologies also, they are around switches, basically, because the network is formed. See how many networks are formed here, at least from the switch perspective. Based on the number of ports that a switch has, you can see that there are 40 port, there are 36 port, I think. There are different kinds of switches. This is a switch, this is a switch, and all these are switches. This much of, with this switch actually you can form very very big networking stuff. Particularly, let us say you go to malls actually, you go to Carrefour, I think Carrefour is there. You go to Carrefour, uh, nowadays actually most of the malls also, or supermarkets also, they give you free internet connection. you know so Carrefour is always very busy, and then people stand in the people will be roaming in the Carrefour, so they also need network, for example. Then Carrefour consists of different networks. That means one network in Carrefour may be for the public, one network in the Carrefour for their internal purpose, one is for other purpose, one is for, again, some more networks are for public, and some more networks are for internal purpose. If you talk about, let us say, Dubai airports, so maybe we don't know how the network is formed, but definitely the networks that is given to the public is not the same network that is internally used by the airport authorities, maybe ground staff, maybe different airline companies. apart from Emirates. So the network is pretty important, and then the basic building block of building a network, the basic building block of network is a switch, because all external connections mostly they come to switch, and then they plug in, then they plug out from the switch, and then so they take it, they plug in their network, and then they plug out their network, and then connect it to a routers or something like that, or any other wired networks or wireless networks. Maybe a printer can be connected, or whatever, right? So yeah, the network is formed using switch. So nowadays switches are also coming with OS, firmwares, and switch contains multiple ports as well. There are again two types of switches, no, managed and unmanaged switches. Managed switch means it has got more configuration options. It has got website facility where a portal is given by Cisco or Aruba network. You can go to the portal, and then you can always manage the whole switch. Generally that's all big switches. As I said earlier, I worked in Aruba networks, where Aruba is pretty famous for switches and routers and network access points. So switches are, you can go to their Aruba Central is one of the I think main website. You can go there as a customer. You can list down all the switches, and then you can perform any operations on the switches. Just SaaS based model. They use it. You don't need to go actually to the switch, connect the switch to a computer, and then go and then use their command line and configure the switch. Those are all little olden days. Switch also comes with operating system, and switch also has got their own command line tools. So CCNA, all these exams, they I think I'm not very sure. I'm not very sure about CCNA, but yeah, generally I think CCNA, all these exams are on how to use their network switches. Okay, and then there are layer 2 switches and then layer 3 switches, because the same concepts come also in the software defined networking, switching, routing, and all. That's the reason particularly we want, you're going to form a network in Kubernetes. Definitely switching and routing comes into the picture, but switching and routing is mostly software defined switching and routing, but the concepts are same. Whatever the physical switch does, even the virtual switch also does the same. So L2 switches are something like you already aware of that MAC addresses. So it contains a 48-bit address. I'll explain MAC address later on. That MAC address is pretty important because L2 switches, they are not aware of actual IP addresses, because IP addresses are not even formed at switches. Okay, they are not care about, they don't know about IP addresses. Okay, and there are L3 switches. The concept is switching. Okay, whatever the operations that a switch has to perform, the same operations this L3 switch or L2 switch will do, but L3 switch is more granular, and then they call it as multiplayer switch. That means it consists of the mechanism of a switch, and then it consists of routing tables. Routing tables are very important. I'll show you later on how to see routing tables. Routing table is what, how to route. No, two employees are in the same network. So for example, not that you're trying to connect to the database, then you are unable to connect to the database. The first thing what you do is you just perform ping command from the client machine to the server machine. Client machine means I'm not talking about your web browser. Client machine means who is the client for your database server. Your, maybe your web server is the client. Database server is your web server. Machine is unable to connect to your database server. What you do, you just go and ping first thing. All right. So that ping operation tells that No, there is an IP address with the ping. So where it has to route, the targeted IP address is in the same network or targeted IP address is in the outside network is decided by routing table. Routing table is something like it route. Okay, so that's what the routing table is. So switches also comes with routing table. Uh, so it is able to perform virtual LAN, virtual VLAN, virtual LAN communication and packets routing between different virtual LANs, because these all different LANs are performed on the switch, and then packet routing between one. So there is a network created in this cable. It is inserted, and then there is network established with this in this particular port. Then you know uh, the most important thing is why routing is important is there is a protocol called ARP. We will discuss about that actually, and then how what is the uh, concept of mapping between uh, the MAC address of a network interface card, the MAC address of a device to the IP address is layer 2 thing, but even switch does that on layer 3 thing by forwarding the packets to targeted device. So you need to know actually IP address, you need to know uh, subnet masking and subnetting. You need to know how the targeted devices and how the routing happens, what is the default route, what is the default gateway, what is the broadcast address. uh, so like that you need to know where ARP is very very important. Like that you need to know a couple of concepts to understand whether it is physical network or virtual network. But here we may need more about virtual networks, but still the concepts are same for physical network and virtual networking. Ultimately how they route packets and all are same, so we will discuss about both actually. And the next concept is called routers. You carry routers. We have routers, wireless routers in our home, but we may be having very uh, lightweight wireless routers. That means it may have one radio, it may have less power, less frequency, or whatever the configuration they give. uh, Routers comes with ports as well. That means routers are used to different networks to communicate. uh, there is a difference, okay? Switches are to form different networks. Routers are different networks to communicate. It looks like little confusing. Why different networks to communicate router? So if you look at that, actually uh, you are you have connected to a your router in your home, and then you want to access some portal or some website, example.com. So the example.com is in your network or in outside of your network. Definitely you know that example.com is there outside of your network. So there is a network there, and there is network in your home. Then two networks are joined, or the network communication between more than one network is established by router. So we have to think little a different way in router. Usually we think that routers are to form network. Yeah, routers have it gives you IP addresses, you can connect to router and all, but not only that, routers are used to connect or communicate different networks. So routers uses data packets between computer networks. So router is where if you want google.com, then that tries your router takes to the external network actually, right? So you don't go and directly access from your machine. There is no cable to google.com switch or IP address where it is connected, it goes through your router. You say google.com, first from your machine it goes to the router, and then from router it has to find where google.com is there, and then there is a DNS stuff happens. We will discuss about that later on. But yeah, these are all interconnected things, so we will be discussing these things as well, one after the other. But
Sir,
that's yes, please.
uh, a router is before switch, correct? Or after switch?
Your router is after. It's not about after or before. The home, in your home, whatever you are using router, so do you have a switch at home?
Hmm. No, but what I meant is like in our company, first the service provider's connection should come to the router, correct?
uh it depends on, directly service provider connection. Nowadays there are switches that service provider connection directly come to the switch, and then the network can be established from there as well. Okay, but
Okay.
routers are what do you say, uh, you have a ethernet cable. Generally you have an
Hmm.
ethernet cable that your internet service provider is from. Actually, when you have ethernet cable that is coming to
Yeah.
your router means that cable is, whether the cable is in the next house, in the next building, or the cable is 10-15 kilometers from your home, but that is ultimately, you need to think that that is connected to a switch. Okay,
Oh, okay.
so but from router another network is established inside your home, because all the devices inside your home which are connected to your wireless router, they form a network. And then that router, it has got a cable, that cable is connected to a switch, then it has got its own network. So uh, it all depends on the basically it's all depends on the architecture. But what, as far as I know, what I see, that routers are used to connect to different networks. So that's the reason, from router, inside router, that is your network. Outside of your router is somebody's else network. That means it is your.
Isolation.
It's not isolation. That's how they connect. Okay.
So what you mean is like in our home, the router what we have, it got a switch also inside.
No, 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 no. Switch is not there. Switch is not there. Switch is not inside. You have to know about. There is something called east-west traffic and south-north traffic. There is a very famous the terminology in computer networking. So
Oh,
east-west traffic is among the devices inside your home. Okay, among the devices. That means,
okay.
uh, uh, you can form a network inside your home, because all your devices are have IP addresses that are given by your router. Actually, you can all the IP addresses, the network IP no, each, and I will explain about IP address. They can form a network, but there is a concept called south north traffic. South north traffic means from your home the traffic goes, it's not about your only home anywhere, it the traffic goes outside of your network, which is called south north traffic. East west traffic means the traffic is only inside your network. Let us say you have deployed an application in your organization. So there is a database server, there is email server, there is different servers are there, message brokers and all. uh, that entire traffic is inside your network. Okay, entire traffic is east west network. So you know uh, the data from your web server, it goes to the your database server. From web server, it might be going to your message broker, or from the web server it connects to maybe the email server that is already hosted, or a SMS based server that is already hosted inside your network. The traffic is not going inside outside, the traffic is inside. That's called east west traffic. So here the traffic is inside means the network is formed, all the devices are in the same network. So how do they communicate? All the devices are in the same network means, again it comes to a point where they should be all connected to the router. But nowadays switches also comes with routers, that's what I'm telling. So it's quite tricky concept, because the purpose of switch couple of years ago is entirely different than how the switches are there nowadays. So switch also can route the traffic. So routers are to route the traffic. Routing the traffic means maybe inside your own network or maybe outside of your network. That means external network, what we call it as routing is something like to ensure that the packets that has to be transmitted to east west or south north traffic. East west is entire your own network, south north is external network. So you are sending something to google.com, or you're trying to open a account in or log into an account in Gmail, then which is called south north traffic, because you have performing in your own network but it is going outside of your network. So a router is there where it is providing the communication. So that's what. However, routers are layer 3. So layer 3 is definitely before after layer 2, right? So how the data comes from layer 3 to, again, layer is, again, you when we really look at uh, the the OSI model, that clearly tells that if you look at the OSI model, wait, it's getting loaded. Yeah. So for example, this is one network. So there is a layer 1, so physical layer, and then there is a data link layer, then there is a network layer, there is a transport layer, and then there is a session layer, presentation layer, and then application layer. Layer 1, 2, 3, 4, 5, 6, 7, right? The same way. So for example, if you go and hit google.com, or let us say if you go and hit the same site webwhiteboard.com from your home, you have a router in your home, then your machine, it's a wireless router. This machine is connected, your computer is connected to a router, whether it is a computer or it's a mobile device, whatever it is. So you go and hit here, then there is some DNS service local that we will discuss about later on. Definitely
So which screen are you showing?
which,
Now only I can see.
oh, you are not seeing my web whiteboard?
No, the whiteboard was there, but are you showing some other screen?
No, this one I'm showing, right?
Oh, okay, okay. Now I can see, sir.
What you can see? The
White
diagram.
whiteboard with
Ah,
the one.
Cool.
That's the one. Okay.
Fine. So you go and type here webwhiteboard.com, then there is a lot of process happens at a high level. Definitely it is not found in your network. Then it asks, it goes to the router. It is not found inside your machine router. Then router also doesn't found because it doesn't have any idea about the IP address. Then it has to go to the internet and then get the IP address. After that, it calls webwhiteboard.com. So webwhiteboard.com here is the application that is running in layer 7, http whiteboard.com. So the data first, it should from the wire passing all the layers, data comes to application layer. At the same time, from the application layer, because webwhiteboard.com on your web server, webwhiteboard.com has responded to the client, then it starts transferring back the traffic from your application server to the target, that performing all these three layers are same. You don't need to really worry about these three layers. Come to again transport layer, network layer, data link layer, and physical layer, and then through the physical layer it comes to, through a cable for example, it comes to your router, and from router again it is transferred to your laptop. So these layers are very important. No, you what I'm going to say is these layers are very important. That's the routing happens. So whatever the routing happens, it happens through the layers. Maybe your devices on or on layer 2, which is called switches or L3 switches, layer 2 or layer 3. Generally we call it as a network layer where IP addresses are there. So ultimately the data has to pass to each and every layer, every layer. So it's quite challenging to say, but definitely router is layer 3, so that comes after layer 2. But so layer 2 is here in the Osi model, layer 3 is here. So the data comes, sometimes data comes from here to here, and then return data comes from here to here. So what comes next is how the data is transmitting, right? Both of us standing to each other. So who is first? So you and me standing to next to each other. So who comes after each other? The question itself is quite confusing. From your perspective, it is like I am standing next to you. From my perspective, you are standing next to me. So for me, first I say myself, and then Naveen, or from you, you say Naveen and Jiten. But somebody else has to come. Who is first? So that depends on from which direction they are counting. If they count from Jitin, then Jitin first and Naveen second. If they count from Naveen, they say Naveen first and Jitin is second. So from us, from our home perspective, generally there is a router, and then the router might be connected to a switch or different devices. So for us, we see only routers. We don't see switches. So yeah, that's how you really think about. As I said earlier, sorry, there is also for switches there is also cloud managed networking. Cloud managed networking means everything is managed through SaaS model. Generally, they provide you a web portal or website or a mobile application. Then you can configure your switches. You can configure the solution. Something like you can configure uh, wireless access points, you can configure switches, you can apply security policies and power management, network insights, security cameras everywhere. You can all these things you can perform on cloud managed networking. We will discuss about this later on through a dashboard. So routers, the most important thing of a router, the very most important thing of a router is routing table. The routing table contains where it has to route to. If it has got information where to route to, that's fine. If it doesn't have information also, it brings from DNS search and then it stores that information for some time. The routing is happen at your whether the router is a virtual router inside your operating system, or it's a physical router that you have installed, or a router that comes along with switch, which is called L3 switch, uh, right? Whatever. But the purpose of router, wherever it is, the purpose of router is to route the traffic to a designated IP address. And then the wireless access points. Have you ever heard of wireless access points? Rather than, have you ever seen wireless access points?
Is that Wi-Fi?
No, Wi-Fi is different. Wireless access points. So, wireless access points. Let us say take an example of Dubai Airport. Why I talk about Dubai Airport is it has got a huge uh, network, because Aruba, when I was working on Aruba, I used to see that a lot of Dubai customer related things and queries used to come from the Dubai airports. They have thousands of routers and even hundreds of switches are there in by Aruba and Dubai airports. So Dubai airport has created a separate network for customers to access internet. Customers can come to Dubai airport and then they can switch on Wi-Fi, their Wi-Fi modem, and then immediately it looks for, of course, then we see the name Dubai airport, free internet Dubai airport or something, then we connect to that. That means definitely for security reasons, the network that they give to customers is not the same network they uh, they use for their applications. So they have a wireless network, they form a wireless network, but if they keep on putting new routers, there is a misconception of router and modem. So we used to tell always modem and all. That's a wrong concept. In our wireless, in our home, it's called wireless router. It is not called a modem. So they put, that how big is Dubai airport. So they cannot keep on establishing a new network by bringing a new router, because whenever they bring a router, what happened, it has to be connected from a switch or from network provider, whoever is providing the internet. But the more routers are there, the more networks it forms. If you have two routers in your home, you know really, if you have two routers in your home, then it's pretty difficult to maintain both the routers. You need just a simple thing is, two routers in your home gives you, if you connect to them, if you connect to different network itself, then that means if you choose different router itself, is you are connected to a different network. That's the reason you go to Wi-Fi settings and then select a router, right? Right now here, the Wi-Fi routers are, you can have different routers here. Select a network and then it comes with a lot of networks. You know, these are all. So it's very difficult to form or to manage so many networks. So what they do is they put network access points. Access points are there So it doesn't form a different network. They are connected to, maybe they are connected to routers, you know, wireless access points generally, WAP, wireless access points. They are all connected to uh, the same router, but they can extend the network so that it's pretty easy for the administrator to to manage. They have to manage only one network because ultimately the network is only one, but they have so many wireless access points. It's in hardware. You can configure it. You can perform access some IP address, allow some IP address, not allow, so deny some IP addresses, give only some limited bandwidth to the devices. You can perform all the settings, but ultimately it doesn't form multiple networks. If it forms multiple networks, what happened is it's very difficult for network administrators to manage the network. So the wireless access points are connected to routers because routers form a network for you. And then routers are L3, right? Routers are connected to switches. That's a different thing. So you can connect them through wire or through wireless. Generally through wire. Wire without wire, then we call it as wireless access points. It's sorry, it's not about whether they are connected to through wire or not connected through wire. How the clients access the network, the wireless access points. Whether through wire or to without wire, then we call it as wired or with wireless access points. So this is our there are so many devices. Okay, but the most important thing is for everything, always think that layer 2, layer 3 is very important. As a software engineer, we always think about layer 2 and layer 3. Layer 2 is MAC address and then layer 3 is an IP address. You should have that clarity. How the MAC addresses are converted or search for IP addresses or vice versa is a different story altogether. There is a separate protocol for that that we will discuss about that. There is a broadcast domain broadcasting something like, hey, who has got this IP address, which MAC has got this IP address, something like that. You can you suppose you got a you are inside a mall, then you got somebody's phone. Definitely, as long as you are in India, you will take the phone and run. You don't run, but at least you will raise your hand and ask that, hey, whose phone is this? Or the best way is, instead of asking whose phone is this, because everyone may come and say this is my phone, you can say, I got a phone, has anyone lost your phone? Then maybe 4 or 5 people come that, yes, I lost my phone. Then you ask them, what is your phone name, what is its color, how many inches. Based on that, you check yourself and you validate that that phone belongs to that particular person and give the phone. Similarly, in the network also, sometimes networks cannot route to a exact network interface, which is connected to L2 network. So it broadcasts, hey, I have got a data that I have got some data or packets to be transmitted to you to this particular uh, MAC address. So who has got that particular MAC address? Then particularly L3 routing comes into the picture there nowadays in advances. Then it first checks that what is the association between, what is the
Sir,
mapping. Yes.
sorry. Will the MAC address vary every time like IP address, or it is the
MAC
same?
address is it is a device address that comes like IMEI number. Okay,
Oh, so
MAC
it is something
address.
on the okay.
MAC address is every network interface card. That means every device that has got network interface card contains a unique MAC address across the globe. That's how the actual networking is formed. Networking is not formed because of just IP addresses. Networking is formed because of some standards that are maintained, maybe IEEE standards or something. They are all maintained by the manufacturers of network interface cards. They are well aware of, they follow a standard like IMEI number nowadays. So no 48-bit MAC address, no MAC address is assigned to another device. It's controlled actually. How, who is the organization who is controlling? I'm not aware of that, but it's controlled. So coming,
Okay, sir.
yeah, going to the uh, third concept, which is called the basics of networking, other basics. Before going to this particular concept, just let me